to welcome you all to the open house for the Material Science and Engineering Master of Science and Engineering program. I'm joined here today by two other people. Hao Gao is a current master's student. She's doing research in my research group, and she'll tell you a little bit about our program. And Tom Feketa is the Director of Corporate Partnerships for the Institute of Nanobiotechnology. He'll be talking to you a little bit about the CoOp program that we offer through our program as well. So I want to start off a little bit by talking about Johns Hopkins University. So Johns Hopkins University is a fairly large university, and that I think people don't always necessarily realize. It is one of the largest research universities in the United States. For the last 37 years, we've spent more on research and development, or federal research and development, than any other university in the US, $2.3 billion in fiscal 2015. And there are 9 separate divisions to the university. So the Department of Material Science and Engineering is located in the Whiting School of Engineering. There's also the Johns Hopkins School of Medicine, which is a large part of the university that you may have heard of. The Applied Physics Laboratory does roughly $1 billion a year in research, much of it government related. They're located at a separate campus nearby to ours. The Bloomberg School of Public Health, also a fairly large research institution. I believe it's the largest school of public health in the United States. And then the Krieger School of Arts and Sciences shares a campus with the Whiting School of Engineering. So the undergraduates at Johns Hopkins are all basically go to either the Krieger School of Arts and Sciences or the Whiting School of Engineering. And then there are 4 other divisions. We have a business school. We have some other schools as well, School of Education, very highly regarded. But overall, it's a very large institution. One of the things that I find nice about the university, though, is as you can look at the pictures here and you see the campus that we're on. This is the Homewood campus of Johns Hopkins University. It very much has the feel of a small liberal arts college campus. But you have this feel of a small campus where there's a lot of people, you can interact with other people, you get to know other people in the campus. But you have all of the resources of this very large research university. There are really a lot of benefits there, having kind of the best of both worlds. So our department in particular, the Whiting School of Engineering, is the engineering school at the university. We have 1,600 graduate students, 1,800 undergraduate students, and 2,500 part-time graduate students. 181 academic and 31 research faculty. That has been growing fairly rapidly. So I'm an assistant professor. I've been here about 6 years, and that has gone up noticeably just in the amount of time I've been here. 32 teaching faculty, 43 associated research scientists and engineers, 9 PhD programs, 14 master's programs, 21 part-time master's programs, and 16 online graduate programs. And so this is one of the things that we're building out more. We're also offering an increasing number of courses online, so people don't necessarily have to be on campus or in the area to be able to take those courses. And those are courses that we allow people to take up to 2 of those courses as credit towards their MSc degree in our department. So our department is about 18 engineering faculty. We have 15 or roughly 15 postdoctoral associates, 60 PhD students, 25 MSc students. So that's actually been growing as well, and 60 undergraduate students. But one of the things that you'll see here is we have a fairly good student to faculty ratio. So a lot of the students that you see here, the PhD, MSc, and undergraduate students, get involved in research in the various research groups that we have on campus. Some of the strengths of our research programs in biomaterials, we're a leading department of biomaterials. We do quite a lot of work on energy materials, nanomaterials, and other areas. I didn't list them all here, but we'll go into a more comprehensive list a little bit later on. And so we have in our university, in the Whiting School of Engineering, a number of institutions that really have overlapping interests with our department. So the Johns Hopkins School of Medicine, one of the largest and, in my opinion, one of the best medical research institutes in the world, has a lot of common interests in our department, especially when it comes to biomaterials. And so we have faculty who are jointly appointed in our department and the School of Medicine. And we have students from our department who will actually go over to the School of Medicine and do their research there. So we also have the Applied Physics Laboratory. As I said, it's a very large research institute that does work for the government. It's similar to a national lab. The difference is that the Applied Physics Laboratory is actually part of Johns Hopkins University, and there are research opportunities for our students there as well. So the Institute for Nanobiotechnology, so Tom will talk about that a little bit later on. This was an institute that was founded by members of our department, and it's currently run by one of the faculty members in our department, where they really work at the intersection of nanotechnology and biotechnology and in materials research as well. And there are a lot of opportunities through there. We'll talk about those in a little bit more detail later. And then there's the Environment, Energy, Sustainability, and Health Initiative. This is really where a lot of the activities surrounding sustainability, energy efficiency, leading energy technologies take place on campus. We have quite a few faculty members, myself included, who are involved in this initiative, and so I'd be happy to answer any questions you have about that. The Hopkins Extreme Materials Institute. This is an institute that was formed several years ago with a large grant from the military. It's working to build better armor to protect people and protect troops. And there's something where the work goes, there's work in our department in mechanical engineering and civil engineering. It's a very large effort at our university and also partner universities, such as the California Institute of Technology. So the Institute of Data Intensive Science and Engineering. This is something that gets to the type of research I do. So I do computational research in the Department of Material Science and Engineering. We use computers to try to design new materials. And a lot of what we do now is big data, data mining, machine learning, the type of stuff you're probably reading about Facebook and Google doing. But we do this to try to discover new materials and new material technologies. The Institute for Data Intensive Science and Engineering is an institute that basically coordinates a lot of different data intensive research, such as ours, for different departments and different fields across the campus. And finally, the one I listed there last might seem a little bit strange, the Sheridan Libraries. That's the name of the library system at Johns Hopkins. And we have, as you can imagine, quite an extensive library system spread across our numerous different campuses, a lot of online resources. But the reason I listed it here is because part of what the Sheridan Libraries does is they're a research organization as well. And they work on the preservation and maintenance of old and rare material. And a lot of that is a materials problem. I mean, if you want the papers on your pages not to degrade over time, that's trying to figure out how to get this material to last longer. And they study these materials, try to figure out what these old manuscripts are made out of. And so they work with people in our departments to enable them to better preserve old manuscripts and books. So this is an example. I just listed some of the ones that we most commonly interact with, but it is a large university. And so there are other organizations on campus that we work with as well. And if you have any questions about those, I'd be happy to answer them at the end of this webinar. So the academic program for the Department of Material Science and Engineering, all of the MSc students need to take at least 8 courses. There are 3 required core courses, and then 1 additional core course that is the student's choice. They're basically 3 different, you can think of them as tracks that you can go on. And so we have 3 core courses, 1 in electrical and optical properties, 1 in mechanical properties, 1 in polymers. And you can choose from one of those depending on where your interests lie and make that your 4th core course. You need to take 4 upper level electives. We have a broad selection of electives, both in our departments and in other departments for their material related offerings. As I said here, some of those courses could be online if they're appropriate and they're relevant to what we do in our department. And up to 2 of those electives can be business courses. I'll talk about that a little bit more in the next slide. And then when you take these 8 courses, you can then go in really 2 different options. So one of them is a coursework only option, where you basically add 2 more upper level electives to your course study. And so you have 10 courses in total, and then you can get your degree. And then another one, which is a popular option, is the essay option, where you work with a research group, either in our department or in a related department at the university. And you spend your time here to complete research, and there, by the end of your program, the requirement is that you either need to have a published paper, or if you don't have a published paper, you have to have written basically a master's thesis. And then once it's signed off by our faculty, you can do that in lieu of taking those extra 2 courses. So you can do the 8 courses plus the essay. A typical timeline to completion is about 1.5 to 2 years for our program. So I mentioned in the last slide that up to 2 of your courses can be business courses. And a lot of those are offered through the Center for Leadership Education at Johns Hopkins. So this is a separate division within the university where we offer a lot of professional development type classes. So there are classes on oral and written communication skills, classes on management, classes on entrepreneurship and developing business plans. And so the idea here is that, what we think in our program is we don't want this to just be a technical program, right? This is a program that should help you move on to the next stage in your career. And really, if you're going to be a leader in your field, you don't just need to have the technical skills. You need to be able to do some of these other things as well. For example, communication is very important no matter what career you go into. And so we think it's important to give people the opportunity to develop those skills as well through our program. So we offer both 13-week full courses or 7-week modules that you can put together in some combination. And you can fulfill some of your requirements towards a degree in our department, or towards an MSc degree in our department, by taking some of these courses. So the last thing I'll talk about in terms of our academic program, and here I'll pass it over to Tom a little bit, is the InvT CoOp. This is offered through the Institute for Nanobiotechnology. This gives you the opportunity to do your research for your master's thesis at a corporate partner instead of on campus. And so I'll let Tom describe this in a little bit more detail.
Okay, so the program is very new and was established on a pilot basis within the School of Engineering roughly 1.5 years ago, and it has been open to students in material science and engineering and chemical and biomolecular engineering at this point, but we hope to spread it through the rest of the School of Engineering. The fundamental difference between this program and other types of education programs is that the work that the student takes actually a definable project, if you will, with a quote. So it's not expected that the student just goes and works in an operating or a research area and does engineering work. It is anticipated there's a project that is a beginning, a middle, and an end. At the end of it, we expect the student to write the results of the work up and then defend it in a manner very similar to the master's essay program that happens with research on campus. The beauty of this is that the student who gets chosen for this program actually goes to a local company and gets paid. Our expectation is that the company pays the student essentially market rates for new graduate engineers, undergraduate engineer, BS engineers, and our expectation is that the student gets a holistic view of the activity within the company. So you have a nice quote there on the slide from Andrew Beamsdorfer, who was actually the very first student to go through this at Becton Dickinson. He did a number of projects because things change, but he got exposed not just to the research and development side, but to the business side, to business development, to the marketing department, to safety organizations. So he got a really holistic view of what life in a corporation is like for a new engineer for 6 months. The same is true of students who went to MedImmune, Lonza, and others. As I said, we currently have 7 companies who are ready to participate in this effort. The process is fairly simple. You apply, you send in a resume, a cover letter, and at least 1, hopefully 2 faculty recommendations. We review those recommendations with an InvT. There's usually an interview process that goes through, and I look at on campus, and then we forward your resume to the company. The company has the right and privilege to say, yes, we want you, or no, we don't want you. And this is a hiring process at the company. They bring you on board. You choose an advisor on campus who will be responsible to make sure that your Hopkins piece of your education goes on, i.e. the project moves along, the project is appropriate, equivalent to a research project that would be an essay type project at the university. And then the advisor will be one of the people in your review committee. We make very sure that intellectual property of companies is protected. So you write up your program in a way that it does not reveal corporate secrets. Program is really, as I said, is gaining momentum now, and we really look forward to new students and new companies being involved. And one more point: while you are on the co-op assignment, you're essentially a non-resident, so you will owe Hopkins something like, I believe it's 8 or 10% of your tuition, and you will not be able to take courses. So it fits very readily into the year and a half kind of time frame that Professor Muller was talking about, because you take your courses in 2 semesters and you research in 6 months, and essentially you can be done. We are reasonably flexible in terms of scheduling. The co-op periods are normally January to June or June to December. They are flexible in terms of whether you take it your 2nd semester or your 3rd semester, depending on how you can fit the coursework around it. So if you have any questions, just let me know.
Okay, thanks, Tom. So I'd like to move on here, and we'll take some questions for Tom at the end of this presentation. But I'd like to move on and talk a little bit about some of the research areas in our department. So as I mentioned earlier, we have research in a number of different fields of material science and engineering. So among those are biomaterials, nanomaterials, energy-related materials, computational materials research, so that's the type of work that I do. We study polymers, we study structural materials, the type of materials that you can build things out of, and there are more. I didn't list them here, but here are some of the main research areas in our department. If you'd like to find out more about the different types of things that we're doing, you can go to these 2 links that I've provided here. The first one lists the faculty who are in our department, and it also provides a brief summary of the research that they do. The second one lists faculty who do materials-related research at Johns Hopkins, but they are not in our department. So these usually have joint or secondary appointments in our department, but their primary department will be, say, in the medical school or in civil engineering or in mechanical engineering or chemical engineering, but they still do work that is basically material science and engineering. So you can take a look at those and see if there are any research interests that overlap with ones that you might have. So I'll talk a little bit now specifically about, give you an example of some of the research that goes on in our department. I'll talk about my research because that's the stuff I'm most familiar with, just to give you an idea of the sorts of things we're working on. The first one, I'll talk about catalysts for fuel cells. So, hydrogen fuel cells have received a lot of attention as a possible way to replace the internal combustion engine. Hydrogen is a fairly high density fuel, and when you burn it, you create water, fresh water. And so from an environment and sustainability point of view, there's a lot of appeal to this. One of the challenges with these fuel cells is that the catalysts they use for the reactions right now, for the necessary reactions, are usually made out of platinum. And platinum, as anyone who's tried to buy jewelry knows, is a very expensive metal. It drives up the cost of the fuel cells. And so there's been a lot of research into try to seeing if we can find something that's better than platinum for these fuel cells. And it turns out that if you mix in some nickel with the platinum, you actually get better catalysts. It's nice that they're more active for the reaction, so you need to use less of the catalyst. And because you've replaced some of the platinum with nickel, you've driven down costs that way as well. The only problem with this is that those catalysts with the nickel in them tend to degrade over time in the fuel cell because the nickel dissolves away from the catalyst. And so some collaborators of ours discovered that if you put a tiny amount of molybdenum in these, just about 1% molybdenum, you can really stabilize these catalysts and prevent this dissolution from happening, but they didn't understand why. And so they asked us to help them out, and we found, and what we're looking at here are 2 results of calculations we did, simulations on octahedral nanoparticle catalysts. These are the ones they synthesized. And what you're looking at is which elements are in different sites in the nanoparticle. We're looking at the second layer of the catalyst here, but it turns out when you expose these to oxygen, you get a similar result for the first layer. And so what we see is that when you don't have any molybdenum there, the nickel likes to go along the edge of the catalyst. But then when you put in a little bit of molybdenum, so this is now the diagram to the right, the molybdenum also likes to go along the edge, and it actually displaces the nickel. And what happens is those edge sites are the sites that are most vulnerable to dissolution. They are bonded to the fewest atoms. So they're the most likely to come off. And so when you put molybdenum there instead of nickel, you stabilize those edge sites against dissolution, and that's what makes these catalysts last for a longer time. And so I'll move on to another project that we did a little bit. This is a kind of a fun one, because this is a machine learning project. So here we studied amorphous silicon. It's a photovoltaic material, so people use it in solar cells. If you've ever had a solar-powered calculator, then you've probably seen amorphous silicon. That's probably would power your solar-powered calculator. It's an old and well-known photovoltaic material, but it suffers from a problem in that holes, which are basically an absence of an electron, get stuck when they're moving around the material. They encounter these things that are known as hole traps. And because of that, the material is not as efficient as we would hope it would be as a photovoltaic material. And so there's been a lot of research over the years into what causes these holes to get stuck. And so what we did is we generated computationally a sample of thousands of different possible amorphous silicon structures. And for each one of them, we figured out where the deepest hole trap was. And then we pointed a machine learning algorithm at this data set, and we said, find us the pattern. Tell us what it is about these samples that causes hole traps to be particularly deep. And within a few minutes, it was really remarkable. The machine learning algorithm found everything that people had found before. Some people looking at the exact same data set have spent about a year looking at this data set and have found some patterns. The machine learning algorithm found all of that in a matter of minutes, and it found more. So this is an example of really where we are in this field, in that this is one property of one material, but the amount of data we generate just with this one property, this one material, is at the point already where machines can analyze it better than humans can. We're getting to the point where the amount of data we generate, now we have databases of properties, hundreds of thousands of materials. There's just no way for humans to manually sift through that and recognize the patterns as well as machines do. So the types of big data analysis that you read about in other fields is also very much occurring in our field. This is an example of research. We have a lot of other stuff going on in this area as well. So we'll talk a little bit now, or we'll actually introduce you to Hao. She's a current master's student in the program. She's doing research in my group. So she can maybe describe just a little bit of her student experience and what it's been like to be a master's student in our program.
Hi, I'm Hao. I'm the current master's student from Baltimore City Engineering. This is my second year, and I'm glad to be here to share my experience in Johns Hopkins Engineering. I'm now working on the 8 courses with thesis program, and actually I think it is really a good practice to enter a research group during the graduate study. My research group is focused on computational materials, as mentioned before, and now I'm working on the catalyst for hydrogen evolution reaction. Based on this research, several different materials are chosen and sampling how hydrogen bonding with their surface. It's really the research group provide me a good chance to to focus on the research study. Also, we have the chance to share our research with students from different schools. Like before, we have video meetings with students from Brown University. So it was a good chance to notice what the others doing on your research field. Also, the professors and the PhD students in the groups are really friendly. So just in my group, we have group meetings every week. So we can share the results of our recent research to the others and also get the knowledge with what the others did in your group. So then come to the courses, we have courses in small groups, and both PhD students and master students are in the same classroom. The classroom is always highly active, and we can have a discussion in the class. Also, the professors are really willing to answer all kinds of questions, both in class and after class. Also, this kind of environment helps us to notice what the other groups do and what the other PhD students focus on. So it's really nice to have like this kind of courses based on my experience. Also, it has mentioned that no more than those major courses, we have the courses from from the Center of Leadership Education. And I have choose one of the professional writing and presentation course and also a management consulting course before. So those courses help me on how to build my resume, how to build my LinkedIn website. Also, the professor from the management consulting are from the real consulting firms that really help you to get notice about the field that out of materials. So I think I can learn a lot more than on the textbooks, and so professional knowledge. Also, those knowledge experience help me to notice how I can develop after graduate, even though I do not want to choose the academic road, but I want to enter the industry field. So this really helps me a lot. If you have any more questions, you can just ask me after later. I'm really glad to answer all the questions. Thank you so much.
Okay, thank you, Hao. That's great. So Hao will also be taking questions along with Tom and myself at the end of this seminar. And so one more thing I want to talk a little bit about is where Johns Hopkins University is located. So Johns Hopkins University has a lot of campuses, but our program is at the Homewood campus in Baltimore, in the United States. So Baltimore is actually, it's a very well situated city. So on the east coast of the United States, you have a lot of highly dense population centers going from Washington, D.C. up to Boston. Baltimore is in the middle of this. So we are about 1 hour from Washington, D.C., about 3 hours from New York. You can make it up to Boston in not much more time, especially using the high-speed train that we have going up and down the coast. It's a great city for restaurants. So we have a lot of up-and-coming chefs like to open their restaurants in Baltimore, in part because there are so many people around here. And so it was recently ranked as the #2 food city in the U.S. in 2015. I'm still going through my list of restaurants I want to try in the city, and I've been here 6 years. I haven't gotten through it yet. The Entrepreneur magazine has rated Baltimore as one of the nation's hot startup cities, especially in fields, medical research, in fields of computer science and computer security. There are a lot of hot startup companies coming out of our university. And in material science, we've had a number of startups spun out of our own department that were founded in Baltimore City. So inside the city, there are a number of different regions. So next to the Homewood campus, there are a couple of neighborhoods. Remington is the neighborhood that is to the west of the campus. It's a great little neighborhood where it's where I'd be living if I were a graduate student. They have all sorts of walkable streets, little shops, cafes, restaurants. It's a very relaxed and friendly vibe, and within walking or biking distance to the university. On the other side of the campus, on the east side, is Charles Village. A lot of some more old Baltimore traditional row homes. Here you see a lot of the undergraduates living. You still have a fair number of graduate students, even some professors who live in this area. And this is really the college town for the Homewood campus. This is where you have the big bookstore, where you have even more restaurants and stores you can shop in. And once again, easy walking distance to campus. It's where I'll often go out and get lunch there during the day. We have a number of events that go on throughout the city and around. There's Artscape, a big art festival. There's Hun Fest, which sounds bizarre, but it's really a Baltimore cultural festival. Hun is a traditional Baltimore term of endearment. And so in Remington, they celebrate this. We have a marathon. We have a professional baseball team, professional football team. And if you like sports, because we're so close to Philadelphia, Washington, D.C., New York, I mean, you have numerous opportunities to see different sports teams. You can see, I think we have 2 professional NFL teams that play in the state of Maryland. So we have quite a good sports scene around here. Johns Hopkins itself has a nationally competitive lacrosse team. If you would ever like to see a lacrosse game, there are a few better places in the world to see it than here. People get really excited about it here. Hamden has been ranked, it's a neighborhood nearby. So Hamden is ranked #8 hottest neighborhood in the US in 2016 by Redfin. So Hamden is just right near Remington, just to the west side of campus there. Very good neighborhood to hang out in. Again, it's the type of place where graduate students, I think, can really enjoy life. And so where do students go when they're done with our program? So when students graduate with our program, and this is for all material science students who come through our program, they go to a number of different routes. So quite a few students go into industry. They've gotten jobs in recent years in Intel and Merck. Well, I won't read the whole list here. But these are examples of some companies. And what I haven't listed here are some companies whose names you might not recognize. And these are the local startups that they go to. And so there are a number of startup companies as well that, either founded by professors at Johns Hopkins or professors at other nearby institutions, where students go and they try to get it on the ground floor of something exciting. People also go to government. We are located within an hour of Washington, D.C., the capital of the United States. There are a lot of opportunities for government jobs around here and a lot of opportunities to make contacts in the government. And so there are a number of research labs around here where people can work, and also for people who are interested in pursuing policy work. There are a lot of opportunities for that as well. Not to mention defense contractors, consulting firms, etc. There's a very large economic system around government work in this area. And then, of course, a lot of our students go on to do research at other universities. So the undergraduates go on to get master's or PhD degrees. Our master's students will sometimes go on to get PhD degrees in the other universities. Some of the universities our students have gone into in recent years, MIT, Northwestern, Columbia, Yale, I mean, some of the top universities, not just in the United States, Oxford, Cambridge, but some of the top universities in the world. And we, in turn, get a lot of students from those universities. That there's a lot of, you kind of build a community here among some of the top research institutions in the world. And so the admissions requirements to get into our program. So you can read about this online. I've provided the link at the bottom of the slide here where you can get all this information. But basically, we would like to see, ideally, a bachelor's degree in engineering, science, or math. But even if you don't have a degree that's explicitly in one of those fields, if you've demonstrated that you have knowledge of these areas, that's sufficient. There's no hard requirement that you have to have a degree in one of these areas. You need to fill out an online application form. You can access it through the site that I've listed in the bottom there. Provide a statement of purpose. So why is it that you want to get a master's degree, and what, how does your background qualify you for a program? Provide a transcript of your undergraduate work. Your GRE scores. So GRE scores, I list here the median quantitative score for the fall 2017 class. So it's relatively high. We get good students in this program. But I will also say we do take a close look at your verbal and written scores as well. All the classes here are spoken in English or taught in English. And we found that basically that the people who can communicate well and can understand English well tend to do better in our program. So we do encourage people to take all aspects of the GRE seriously when they're applying to the program. You need at least 2 letters of recommendation. We'll take more if you have more. And if you are not a native English speaker, we do ask you to take either the IELTS or the TOEFL, test, just to demonstrate English proficiency. There's a $75 application fee as well.